Okay, so now we're doing 7.4 trig identities, and in this lesson we're going to continue to use algebra concepts related to trig. There's many trig identities you need to become familiar with, including when you have to solve for an expression in a Pythagorean identity. Sort of like when we had sine squared x plus cosine squared x equal 1, we could have said sine squared x is 1 minus cosine squared x, or cosine squared x equal 1 minus sine squared x. So it's similar to what we've done before on 7.3, but it's a little bit extra because you're going to have extra Pythagorean identities. But this is a very good summary of everything we've done lately. By the way, this is called analytic trig. Okay, analytic trigonometry. Okay, so to start with, two functions f and g are said to be identical equal if f of x equal g of x for every value of x for which the functions are defined. I'll give you an example. So for example, sine squared x plus cosine squared x equal 1 for every angle. Not just certain angles like pi halves or pi or whatever. Now compare this, and this is a good question leading into this. Compare that to let's see, do I have that here? Yeah. To 3x minus 2 equal 10. I'm just doing a really basic linear thing, a linear equation. And so you add 2 to both sides, so you have 3x equal 12, and then x equal 4. If you remember from geometry, we have a term called conditional, and that would be if 3x minus 2 equal 10, then x equal 4. And we can even say if x equal 4, then 3x minus 2 equal 10. So those are called conditionals. The first one is called an identity. So if it could be for any angle, it would be an identity. But if it's only a certain value of x, then it's not an identity, and it's called a conditional equation. So in the case where x equal 4, then 3x minus 2 equal 10. Obviously that would not work if x were 10. And so that's called conditional. It's not an identity. Okay? The next ones are pretty good summaries of what we've already had, which is pretty good information. The first one has to do with division, and it's in terms of sine and cosine, so we call those quotient identities, and that'd be tan is sine over cosine, cotan is cosine over sine. Also, some people like to think of it as y over x and x over y, which is fine. But the quotient identity would be sine over cosine for tangent and cosine over sine for cotangent. The next ones are where you have 1 over some expression, so those are called reciprocal. The reciprocal identities are cosecant equal 1 over sine secant equal 1 over cosine, and cotangent equal 1 over tangent. You can also even say sine theta is 1 over cosecant theta. I'm not going to go through all 6 combinations. It's kind of redundant. The ones we use are when it's something unusual like cosecant, secant, or cotangent, and then we'd turn that into sine, cosine, or tangent with 1 over those. But just remember, if you were solving for sine, then it would have been 1 over cosecant. So those are called reciprocal because it's 1 over a number. 1 over an expression. Reciprocal. Number 4, this is where you have sine squared theta plus cosine squared theta equal 1. These are Pythagorean identities. And that's probably the only one you've used so far, other than saying sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Now, the next part shows you another one, and this is tangent squared theta plus 1 equals secant squared. So that comes from the original, but dividing by cosine squared. From the original and divide by cosine squared theta. So think of that as sine squared divided by cosine squared turns into tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared. So that's how that identity even exists. Okay? The next one, what they're going to do is divide by sine squared. And it's in a little bit different order, but this is how it came about. I'm going to rewrite this as 1 plus cotangent squared, by the way. So if you do sine squared divided by sine squared, you get 1. And if you do your cosine squared divided by sine squared, you get cotangent squared. And if you do 1 over sine squared, that's cosecant squared. Yeah, so it all comes from that one identity. There was even a way in a Professor Dave video, which I'll show y'all, about this. About how this was originally x squared plus y squared equal r squared, and we'll show that after this. So those are your Pythagorean identities. Now, remember, whenever we have new identities, you might need to move the 1 over and say tan squared is secant squared minus 1. And you might, on this one, solve for cotangent squared, so you do cosecant squared minus 1. So there are going to be different variations of them. The next part that we're talking about are the even-odd identities. Even-odd identities. And these are when you have sine of negative theta is negative sine, cosine negative theta is positive cosine, and then there's your others. Tangent would be negative tan, cosecant would be negative cosecant, and secant is positive secant, and cotangent is negative cotangent. So what we've talked about before in some problems are like the reason behind this. When you have a negative theta, whether it's in the sine negative or whatever, that means you're going backwards, and we need to relate it to when you're going forwards, like a positive theta. So when we're talking about cosine, cosine relates to x, and so negative theta would be equal to positive theta. That's why over here it has cosine negative theta equal cosine theta. Because cosine is positive in 1 and 4. So that's why it's just equal to it. Now on the other hand, we've got a sine of a negative theta, and so down here it's going to be an opposite sign than when it was here. Because sine is positive in 1 and 2. And then the others are like it. Tangent would change signs, that's why it's negative. Now cosecant is related to sine, and so that's why it would have a negative, meaning the opposite. Cosine is related to secant, and so that'd be the same. And then cotangent would be an opposite sign, like tangent. So that's where it comes from. Again, this is just a really good summary of things we've been doing. Number 6, the list of quotient, reciprocal, Pythagorean, and even odd identities are called the basic trig identities. Basic trig identities. The harder ones we're actually going to skip. It's going to be about the, I was going to say addition, the sum and difference. And there's also some quotient ones. These are in the back of the book. Okay, so in the back of your textbook, it doesn't have a page number, but it says trig functions, and there's your list, and then it says of a general angle, there's your list. It also has your fundamental identities,